Here we are again in the Simpkins Physics Corner. It's time, ladies and gentlemen, today for some free response questions. Hope you checked out the multiple choice video I posted earlier. Let's get into it. This is from the 2017 AP Physics 1 exam. Question number 4. I just had my second cup of coffee for the day, so I am turned. Let's get it. All right. A physics class is asked to design a low-friction slide that will launch a block horizontally from the table of a lab table, or horizontally from the top of a lab table. Teams 1 and 2 assemble the slides shown above and use identical blocks 1 and 2 respectively. Both slides start at the same height, d, above the table. Yeah, very good. However, Team 2's table is lower than Team 1's table. To compensate for the lower table, Team 2 constructs the right end of the slide to rise above the tabletop, so the block leaves the slide horizontally the same height h above the floor as Team 1's block. See figure above. Both blocks are released from rest at the top of their respective slides. Do block 1 and 2 land the same distance from their respective tables? So the reason I started you guys off with this is because we're talking about energy for this problem. This is where you have to be able to read good, but also interpret a diagram good. And let me explain. We notice that both blocks will start from the same launch height, h. And so the question is asking us, will they go the same distance from the table? Will they both fly out the same amount? Well, what's that going to depend on? That's going to depend on how fast they're moving horizontally at the edge of their tables. Now, we know that since they both have the same height h as far as their initial y position of their launch, they're going to both accelerate downward at the same rate due to the acceleration of the force of gravity that is caused on them. And they are then, so what we're really asking here is, which are they going to go the same distance from the table, or is one going to go further, or what's the deal with that? Well, that's all going to come down to how much velocity they have. Now, where are these blocks getting their velocity? Well, they're getting their velocity from the potential energy that they start with being converted into kinetic energy by the end of the table. So this question is really asking which block is going to have the most kinetic energy flying horizontally off the edge of the table. Whichever one has the most kinetic energy will go the farthest horizontally, since they're both falling the same distance. Well, I hope that if you're looking at the diagram carefully, block 2, and you notice they throw all these dashy lines in here. They're pretty much screaming at you, like, pay attention to the details. Because block 2, yes, it starts a distance, or sorry, I should say a height d above its respective table, but that's kind of irrelevant, all right? Because we can, it's 2020, yo, we can set the reference point for potential energy wherever we feel like. And in this case, the potential energy reference height is going to be this dotted line. I don't know if you can see my little cursor there. It's going to be that dotted line there. So let's get to the big idea. Which block started higher above that reference line? Answer, block 1. Therefore, block 1 started with more potential relative to that launch height than block 2 did. And if it started with more potential and there's no friction, which it says there isn't, then that means it's going to have mucho kinetic energy as it's going off the table. Therefore, it's going to go farther. So that's kind of unpacking the ideas in your head, and then it comes down to how do you write this. So let's look at the question they're asking. Both blocks are released from rest. Do block 1 and block 2 land the same distance from their respective tables? No, of course not, you fool. All right, no, not you fools, but I mean, they're the fools. And I'm going to go ahead and change it up here to go to the text box to kind of justify my answer. Okay, so we focus on the big idea of energy. Now, you notice this is a 7-point problem, only give you 13 minutes. So when it says justify your answer, it doesn't say in a long-form paragraph response. It just says, give me a justification. Okay, so we want to keep this as short and sweet as possible. But we do have to note the subtle differences here. So we could say, for example, all right, the distance the blocks travel from the table will be determined primarily by which block has the largest horizontal launch velocity, since they both are launched from the same height above the ground. When they reach the end of the table. The nice thing about the AP exam this year is that you can submit it in lots of different kinds of formats. So you can notice how much faster I can type this than I could write it by hand. I would highly suggest getting yourself an arrangement for a PowerPoint slide or some way that you can quickly type out ideas so that you're not wasting time writing everything out. Plus, I can make quick changes if I phrase something and I'm like, oh, that's garbage. Let me rephrase that. All right. So the distance the block travels from the table will be determined primarily by which block has the largest horizontal launch velocity, since they both are launched from the same height above the ground when they reach the end of the table. Therefore, since block A starts with the most potential, if I can spell good, energy relative to the launch height, it will have the most kinetic energy when it reaches the end of the table, and thus it will travel a greater distance from the table than block B. Boom, next question. All right, so that wasn't too bad. We're only 6 minutes into the video, and some of it was me farting around. So that's a quick little explanation for this first part. Let's go to the next part. In another experiment, teams wanted to use tables and low-friction slides with the same height. Sounds fair. However, the two slides have different shapes, as shown below. Both blocks are released from rest at the top of their respective slides at the same time. Which block, if either, lands farther from its respective table? Okay. Now, I'm doing all this explaining. That's why it's taking us longer to answer this question. But I hope that you're looking at these big ideas. You're like, okay, well, they both start at the same height from the edge of the table. Therefore, they're both going to be on the same speed. And it says which one lands farther from its respective table. You're going to say, well, duh, they're both going to land the same distance from their respective table. All right. So it says briefly explain your reasoning without manipulating equations. So maybe we can say something like, although the blocks travel different paths to get to the end of the table, they both experience the same change in UG. You are allowed to abbreviate if it says briefly, especially. So they will both have the same kinetic energy at the bottom, and therefore, with the same launching speeds, they will travel equal distances from the table. Now, I won't mention any names, but especially those of you with bad handwriting, you're definitely going to want to practice doing these questions digitally, all right? Because people judge you on your handwriting. It's just the reality of how life works. Part 2, which block, if either, hits the floor first? All right, so now we're talking about time, but you got to be real careful, okay? Because it says that they're both released from the top, and you're real tempted to be like, well, they travel the same horizontal distance, so obviously they hit the ground at the same time. Or do they? Let's consider how these blocks would move. This guy is going to yeet down the ramp really fast, the physics technical term. And this one is going to be, yes, it will arrive with the same speed at the bottom, but you notice that it's taking a longer path. You can just imagine how fast this guy would gain speed, how fast block 1 would accelerate, whereas block 2's average velocity from this point to this point, or should I say from the top to the bottom, is going to be lower than block A's average speed because it's not going to accelerate as fast. Now, will it eventually get to the same speed? Sure. But basically what's going to happen is, although they travel the same distance from the table, block A launches first, so it hits the ground first. So while block A is like, clunk, this guy's like, wait, and it's trying to catch up with it, force of gravity. If we said that, good job. All right, so which block, if either hits the floor first, this one's going to be block 1. Now, this can be a little tricky to explain, but let's try to keep it as concise as possible because it does say briefly explain your answer. So let's do it as briefly as possible. I'm going to say something like, block 1 arrives at the edge of the table first due to its greater acceleration according to the shorter path it travels. So block 1 launches first, and it therefore hits the ground first. And this is why you type it, because I don't like that. So I'm going to say block 1 leaves the table first. Okay, sweet. That's it. Okay, block 1 arrives at the edge of the table first due to its greater acceleration according to the shorter path it travels. So block 1 leaves the table first, and therefore it hits the ground first. All right, cool. Let's evaluate our response. Let's see how we did. I'm going to flip over to the Magic Grading Guide. Ooh, now these are available online. You can find these. All right, so let's score your response for the first one. It said, for attempting to use conservation of energy to compare the two blocks. We did that. For explicitly or implicitly indicating that the launch velocities are different. Okay, let's see. So they are launched from the same height. Distance block travels will be determined primarily by which block has the largest horizontal launch velocity. Ding, got it. Point number 3, for stating or implying that the time to reach the ground is the same for the both blocks. All right, so let's see. Now, it did say state or imply, and I implied it right here. So this is what they mean by imply. Since they're both launched from the same height above the ground, when they reach, say the distance they travel, I think you'd probably get that one. All right, we could be a little more explicit with it, but time is a factor. So you can see a sample response right there. Let's look at the second part. All right, we got the correct answer. Correct answer, 2 blocks land the same distance for indicating that the change in potential is the same and for an indication that the launch velocities are the same. All right, let's see how we did. Although the blocks travel different paths, they experience the same change in UG. All right, got that point. So they have the same kinetic energy at the bottom and therefore the same launching speeds. Point number 2, got it. All right, so we picked up the 2 points in our response here. Last one, for indicating the average speed or velocity on the slide is higher for team 1, or block 1 reaches maximum speed in less time, for a valid explanation why the average speed or velocity is higher, or why block 1 reaches its maximum speed in less time. All right, so here's an example. Because the ramp table 2 is initially steeper, block 1 has a higher average speed. Now, they say you have to address average speed. What did we say? All right, arrives at the edge of the table first due to its greater acceleration according to the shorter path it travels. So block 1 leaves the table first and therefore hits the ground. I wouldn't want to be a grader for this one. They'd probably acknowledge that you know what's going on. The problem is if they look at the sign on the wall that says no mercy, no exceptions, they might have a hard time. Now, you see what I'm getting at here. It says we have a greater acceleration, which implies a greater average velocity. So that's why I think we'd still be safe to pick up the points here, because you have no idea. I mean, we're going to learn a little bit about what they look for in grading guides, but it can be pretty tricky. But I hope you guys were paying attention to the details. We saw some conservation of energy. I saw some conservation of energy here. We saw some projectile motion, and we saw the different paths traveled. So hope you guys found this video helpful. Make sure you like, subscribe to the Simpkins Physics Corner. We're pretty much bringing these to you. Well, it's been daily. It'll probably be every other day from now on, because we're going to fill in the gaps with some Zoom chats. But for today, it's Friday. All I want you guys to do is watch these videos. Hit me in the chat on Canvas. And that's good for the weekend. We're going to call it a weekend. Monday, I'm going to be picking up with you guys for simple harmonic motion. So I'll be working the rest of the day today, getting those lessons filmed and ready for you. We'll have an Albert assignment on Monday. So until then, adios from the Simpkins Physics Corner.